Hello, we are Group 1 for this term project. We designed gradually noisy alarm. Let's start the presentation now. This is our table of contents. This is an overview. When you wake up in the morning, you may have had an experience of oversleeping without listening to the alarm. There may also be an experience of being too loud alarm to be surprised. To welcome a fresh morning, we discussed ways to slowly wake up by raising the alarm sound little by little. Based on what I learned in electronic circuit 2, a subject to be taken this semester, this project implements an alarm clock that becomes louder and louder over a certain period of time by applying an amplifier using MOSFET. In this project, the switching action multi-stage amplifier using MOSFET logic circuit was utilized. In addition, logic circuit was implemented through state diagram and configured to change the gain over time by connecting with multi-stage amplifier. This is a related theory. This is a picture of our overall theory. This is a schematic picture of our circuit diagram. First, the resistance value is changed over time by forming a block through DC voltage and using the flip-flop to form a switch. The input sound is amplified using MOSFET and the gain value is adjusted in the source follower group by adjusting the resistance value through the switch designed before the source follower. The source follower is designed to catch the noise generated by the two-stage amplification of input signal. This is an element for NE555. We use the NE555 element to implement a circuit in which the gain varies with the clock to make the sound louder and louder. NE555 is the element that creates the clock by authorizing DC voltage. By the way, we decided to give power of 12 volt, but and the operating voltage of NE555 element was close to 5 volt. Therefore, using the circuits of 7805 element, 5 volt VCCs were created. The NE555 element has the advantage of being able to be controlled simply and accurately. When operating in the time delay mode, the delay time interval can be precisely controlled through external connected resistors and capacitors. This is the cycle control of NE555 element. It is determined by the frequency, period, on time, off time, and the value of R1, R2, and C attached to the outside of 555 IC. Through the resistors and capacitors we used, we have calculated and found that 4.8 seconds are produced per cycle. Also, we place it different times on and off in the clock. According to the circuit design, 91% is on time and 9% is off time. The ring counter is designed by the flip-flop. For this, a switch is set to change the value of the resistor connected to NMOS and to change the voltage gain. RL1 is 8.3 kilo ohm, RL2 is 33 kilo ohm, RL3 is 150 kilo ohm, RL4 is 200 kilo ohm. The state diagram according to the circuit we designed is illustrated. To operate as shown on the left, the preset and clear had to be energized with high power. We set the initial value to be 0001. Mm, This is theory. This is a theory related to common source amplifier. We used NMOS. Common source amplifier has large volume gain and large current gain, and the input resistance is small and the output resistor is large. At common source amplifier, the coupling capacitor was designed to filter only the desired frequency band. Bypass capacitor blocks DC components, passes AC signals only, and maintains a constant bias current flowing to the source terminal. Source follower designed at the last stage. The source follower was designed to address the noise generated in the middle of amplification in the designed circuit. Source follower has the characteristic of reducing noise and having one gain as a buffer role. This is the speaker we used. We used a speaker with a capacity of 8 ohm and 1.5 ohm. 1.5 ohm. Oh, sorry. We used a speaker with a capacity of 8 ohm and 1.5 watt. This is our PSPI simulation. We represented the parts of the circuit by its use by color. We can divide the circuit into 5 large parts. First, the part that provides two-stage amplification, the part that converts DC voltage into a clock signal, the part that automatically crosses over using flip-flops, the part the MO switch that changes the value of the output by changing the resistance by encounter, and finally the part of the source follower. This is the final result and consideration. On the left is the circuit diagram that we finally implemented. And we recorded the buzzer and the music. First of all, this is the sound of buzzer. And this one is the sound of music. This is our consideration. First, we had a power problem. Power was given to the 9-volt battery, but the volume was too low because it was lower than the voltage required by the amplifier and speaker. So we decided to give 12-volt power to the power supply. Second, we had an amplifying problem. The two-stage amplifier circuit was designed first to confirm that the amplification was working properly. When the multi-stage amplifier circuit constructed, which had two common source amplifiers connected together, there was a lot of noise and the upstage. So um, there was a lot of noise at the output stage. So it was hard to tell what song it was even when the music was played. Therefore, the source follower was added to reduce the noise a lot, and the amplification was good and the music was well listened to. Third, we had a NE555 clock setting problem. It was initially difficult to set the block in a situation where the DC voltage was turned into a signal of the block using NE555. Using the computed values through the capacitor and the resistor, we set the correct clamp for our circuit. Fourth, we had the voltage dividing problem. It was not easy to operate the 7474 ring counter using the clock generated. The two-stage amplifier operates at 12 volts with an input voltage of 5 volts for the D flip-flop. Therefore, the circuit was constructed using the 7805 element, and the voltage divide was successful at 5 volt. Last, we had a 7474 diagram problem. Also, I knew theoretically, but when we set the initial value of 7474, we found it difficult. Therefore, the initial value was set by giving the clear part of Q0 to Q2 through the switch and giving the 5 volt VCC so that the diagram of 0001 to 0010 to 0100 to 1000 can proceed. Afterwards, different resistors were added to the output terminals to implement amplifiers that gradually grew sound and using MOS on and off. So we call this part the MOS switch. This is the schedule we have been doing so far. We proceeded well um, we proceeded well with the project according to the schedule. And this is our role sharing. We divide these roles properly. This is the final budget we used. You can see that budget well organized. Lastly, these are references we have referred to. Thanks a lot for focusing on my presentation. Thank you.